Let's go ahead and look at statistics part 2. What we're going to do is look at our normal distribution, but we're going to look at problems where the empirical rule does not apply. And this is going to be described by a standard normal distribution, which is a normal distribution with a mean of 0 and a standard deviation of 1. So I look at my diagram here. That means that the middle is 0, 1, 2, 3, -1, -2, -3. Now I'm just going to go ahead and label this Z because these are the Z scores. Okay? Z scores are used to measure location from the mean in a normal distribution. Just a reminder, your Z-score formula is data minus mean over standard deviation. These can be used to compare data points from different data sets that measure similar quantities. Okay, different data sets, but similar quantities. Let's go ahead and look at our first example. At a certain college, applicants who take the SAT, SAT, have an average score of this and a standard deviation of this. Applicants who take the ACT have a mean score of this and a standard deviation of this. Both of these are entrance exams for colleges, so they are different data sets but similar quantities. So let's go ahead and look at what we have. Bobby has a 1080 on his SAT, and Kathy has a 28 on her ACT. So the information is color-coded. Let's go ahead and find Bobby's Z-score. Okay, so my formula is up here. Data minus mean over standard deviation. So Bobby's Z-score is data. Bobby has a SAT. So 1080 minus 896 divided by 174. Okay, let's go ahead and 1080 minus 896 divide by 174. 1.06. And we're going to go ahead and round to 2 decimals for Z-scores. Okay, let's find Kathy's Z-score. Kathy scored a 28 with an average of 20.6 and a standard deviation of 5.2. .42. Who got a better score and why? Well, we can't compare 1080 to 28, but we can compare how far above the mean. So I'm going to go ahead and label my Z-scores. And then I'm going to label the SAT. And then I'm going to label the ACT. That means that a score of 896 and a score of 20.6 would be considered equal because they're both the average. Then I go ahead and look at this, and Bobby has a z-score of 1.06, so that is about here. Okay, that's Bobby. Now Kathy is a 1.42. 1.42. That's more here. Right? She got a score of 28, and Bobby has a score of 1080. That means that Kathy has a better score. Because a higher z-score. She's more standard deviations above the mean. If we were thinking of percentiles, she would be in a higher percentile because she has more data points or more percentage below her. The green percentile is larger than the pink one. All right, let's do the second example. Go ahead and try it and then check the answer. Pause it, plus play when you're ready to check. 67 minus 69 over 2.8 negative 0.714, so negative 0.71. Anne is 65 inches tall minus the mean over 2.7, 0.37. Now we're looking at percentile, and I'm not quite sure how to do that yet, but let's draw our diagram. Okay. Z-scores, 0, 1, 2, 3, negative 1, negative 2, negative 3. And we can do men. And I'm just going to label the middle, okay, and women. And let's label the middle at 64, okay. This helps me place my data. Okay, Justin is negative 0.7. Negative 0.7. Okay, this is the area that would represent his percentile. Okay, Anne is positive 0.37. She is 0.37 standard deviations above the mean. So this shaded pink area would represent Anne's percentile. Who has a height that is closer to the mean? Anne, because z-score is closer to 0. Now for the percentile question, we're going to have to wait until we do the next page of notes here. If I were to make a guess on the percentile, I notice that it's between, okay, negative 1 and 0. So I know that right here is the 50th percentile, and I know right here is the 16th. So I'm going to say approximately the 16th, a little more, because I can tell that it should be more than the 16th percentile. Okay. Now for Anne, I can say it's around the 50th. Now I know that this one is the 84th percentile. Okay, so approximately the 50th, a little more. But I make sure to say that it's going to be less than 84. Same thing here. It's definitely going to be less than the 50th, but pretty close to 16 for Justin and pretty close to the 50th for Anne. Now let's say we actually wanted to find these percentiles exactly. That's what we have this chart for. So if you flip to the last page of your packet, you can rip that off and pull that table out in front of you here. Okay, it should look like this. Notice that this is a chart of z-scores. And you're given the first digit, the second digit, and then the third digit. 2 decimal places. Okay, and the tabulated probability. So that's giving us this shaded area. So let's do an example. Here's my z-score, 0 and 1. Now they're saying 0.52. It's right here. And z is less than. That means that I'm shading less than. Now I know that this is going to be more than 50% and less than 84. Okay, I'm going to look up my first 2 digits. 0.5. 0.5. And then I'm going to look up my last digit. 0.02. 0.02. And then I'm going to follow this over and I'm going to read the number where they intersect. That means that this shaded area right here equals 0.6985, which makes sense because it's more than 50 and less than 84. Okay, so let's look at z is less than 2.43. Okay, so it's right about here. So I'm going to shade this area. Now you can't really see this, but there's a little bit of white area over here. So I'll put that as yellow. Little tiny section over here. And I'm going to use my table and I'm going to look up the pink area and I'm also going to see if I can find the yellow area. Okay, so my first 2 digits are 2.4 and then my last digit is 0.03. Notice this is a positive number. 2.43. 2.4. Okay. 2.4. And then I go up to the top, 3. And so where do these 2 numbers intersect? Right here. So I'm looking at 0.9925. 0.9925. 0.9925. Now if we remember, the area under the curve should equal 1. So I'm going to label this yellow section also. .0075. So the probability that z is less than 2.43 is 0.9925 because I was shading for the area less than or to the left of 2.43. Okay, let's do 4 and 5. Probability that z is greater than 2.17. Here's my z-score, 2.17. Now, it's asking for more than. I'm going to shade 2 sections. In this particular case, I'm looking for the pink, which is more than. Just going to shade both sections. Okay. Now I'm going to write another probability statement here. Okay, so I need the pink area. So this could be the whole area is 1, and if I subtract out the yellow, then this would equal the pink. The reason that I switch this to the less than is that your table of values only gives you this number to the left of it. But notice that we can also just shade the other side. The connection is that gray and pink equals 1. Gray plus pink will equal 1. So if you can find the gray number, you can find the pink number. Okay, let's look it up. Probability that z is less than 2.17. 2.1, and then 0.07. Okay, 2.1, and then 0.07. There it is. Up here, come straight down. Okay, 0.9850. 9850. All right, so obviously the yellow number is not what I'm looking for, but I can subtract and I can come up with the other side. 0.0150. Probability of the pink, 0.0150. Let's go ahead and try number 5. Greater than -3. 0, -3. Okay, so here's my line. Now you can't see this, but there is something over here. So I'm looking for this section here. Okay, and there is a little smidge right there. Okay, now my chart is only going to look up the areas to the left. So we're going to rewrite this as 1 minus, I'm going to subtract out this yellow portion. Okay, so I have to look up a z-score of -0.3. If you look at your chart, one side has positive numbers. Look at that area over here. Notice that it's shading positive. If I flip it over, look here, it's shading your z-scores to the left. So I need -3.00. -3.00. 0.0013. Okay, so this side is 0013, which means that the other side is minus 9987. 9987. All right, let's try number 7, and then you can try the remaining 3 questions. Okay, -2.13 and -0.45. Oh, so I'm looking for between. Okay, so between. I'm going to redraw this into a separate picture here. Okay. And curves are a little tricky to draw. Okay. Now I'm going to label both of my z-scores, and I'm going to start with this one, -0.45, and I'm just going to make that one yellow. Okay, and then I'm going to do this one, -2.13. Notice that if we take the yellow portion and we subtract the pink portion, we will be left with the in-between. Okay, here's the pink portion. Here's the yellow portion. Yellow minus out the pink will leave us with that area right here. So we're going to look up the probability that z is less than -0.45, and then we're going to subtract the probability that z is less than -2.13. Okay, here we go. -0.45. -0.45. See if I can find this. 0, 1, 2, 3, 4, 5. And I check the top of my diagram, and yes, 3, 2, 6, 4. Okay, now I look up negative 2.13. Negative 2.1, 0, 1, 2, 3. 0.0166. And subtract 0.3264 minus 0.0166. 3098. This section right here is 0.3098. Go ahead and try questions 3, 6, and 8, and then press play when you're ready. Five, 3, 9, 8. Two point zero one. 2.01. 2.01. 9778. Okay. 1.74 negative 1. Okay. 7, 4. 0, 1, 2, 3, 4. 0, 4, 0, 9. Okay. Let's see. 0.9369. Okay, last section we're going to look at before we take a short break is working backwards. So this time you're going to be given a percentile and you need to find the min and max possible z-score. So when I say the 70th percentile, okay, so 70th percentile means probability 0.70. Remember, probability is a number between 0 and 1, whereas percentiles are between 0 and 99%. Okay, now I have 0.70, and I'm going to go up to my chart, and I'm going to look for anything. Now remember that this is a round down, which means I'm looking for anything between 0.7000 all the way through 0.7999. Oop, sorry. Let's go ahead and fix that. Okay, so 70th percent, okay, which would be 70.99. Now, if I'm going to convert that to the probability, I'm going to move my decimal place over. 0.7099. Okay, so we need the first two digits to match the percentile that we're looking for. So I'm going to go up to my z-chart and I'm going to scan the probability numbers for anything that has a 70 to start. And then I'm going to trace it backwards to find the z-scores. Okay, now the smallest z-score, so z-min, is 0.53. The z-max is 0.55. So let's go ahead and do the 84. Okay, so I'm going to take my chart. Now notice that 84 is more than 50%, so we're looking for positive z-scores. So 0.84 all the way through 0.8499. Okay, z-min, 84. Okay, so here's my chart. I'm scanning for 84. So I notice right here around the 1.0 mark, I see an 84. So I'm going to look forwards and backwards. 84, 84, 84. Okay, and then I look backwards. 8389. Nope. Okay, so this is it. So then I scan up here. So we get 1 point. Okay. 1.00 all the way through 1.03. 1.00. 1.03. 1.00. 1.03. Go ahead and try the next three. Press pause and then play when ready. Okay, 90th percentile, so that's from 0.9000 all the way through 0.9099. Okay. Z-min, so 90. Okay, here's a 9, 0, 0, 0, 0, 0. Okay, then I'm going to look backwards. Aha, okay. This one's a little tricky, so it's going to be 1.209. Okay, so 1.29, 1.29, 1.34. Here to here. 1.29, 1.34. Okay, 93rd. Okay, 93rd. Switch colors, make it a little easier to see. 93. Okay, here's a 93. 93. Okay, I'm going to scan backwards. 93. Okay, here we go. Okay, 1.48, 1.55. 1.48, 1.55. Okay, 45th. All right, 4, 5. So that's going to be less, this is going to be negative z-scores. Let's flip it over. 4, 5 is what we're looking for. Okay, there's a 4, 5, 4, 5. Oh, that's it. Okay. Negative 0.11, negative 0.12. Keep in mind that this one is farther to the left.